Excellent. All right. Well, welcome everyone to our first event of the year. We are Code D. We are Detroit's computational design community. I'm John McGarry. I'm the chair of Code D. Code D is here to empower students and professionals in the AEC industry to learn, share, and implement computational thinking. If you have any comments or ideas for future events, make sure to reach out to us or our great planning committee, or we can continue this discussion on our Discord channel. You can reach out to us on our socials, or if you're curious about any of our previous events or tutorials on Grasshopper, check out our YouTube channel. And while you're there, make sure you smash that subscribe button. So with this lecture, we have a very special guest. Our event is Artificial Intelligence and Architecture, featuring Dr. Matias del Campo. Matias is a registered architect. He earned his master's in architecture from the University of Applied Arts in Vienna and his PhD from the Royal Melbourne Institute of Technology. He's an associate professor at Tamed College for Architecture and Urban Planning at University of Michigan, the director of architecture and artificial intelligence laboratory at U of M, where he conducts research on advanced design methods and architecture, primarily through the application of artificial intelligence. And he collaborates with the computer science department in Michigan Robotics, which he's also an affiliate member. He's been awarded the Accelerated at CERN Fellowship, awarded the AI Studio Prize, elected into the board of directors at Arcadia and IJAC, the International Journal of Architectural Computing. His solo shows include Formations at the MAC in Vienna and the Expedition Sublime Bodies at the Fab Union Gallery in Shanghai, China. He's also the co-founder of the architectural practice SPAN. SPAN gained wide recognition for the design of the Austrian Pavilion at the 2010 Shanghai World Expo. Most recent project is the Robot Garden at the Ford Robotics Building. SPAN works are also featured in the Venice Architecture Biennale in 2012 and 2021, Archilab in 2013, and the Architecture Biennale in Vienna and Buenos Aires in 2019. In 2013, SPAN expanded its operations to Shanghai, China, where the practice is currently working on building projects of various scales. It's my great pleasure to give you one of the leading experts in artificial intelligence and architecture, Dr. Matias del Campo.
Thank you, John. Thank you very much for the kind introduction and for the invitation to speak to you and your fantastic guests tonight. I'm reconvalescent from a flu, so if I have to cough in between, then I apologize for that. Are you seeing my screen? Yes?
Yep. Yeah.
Okay, excellent. So as John already mentioned, I'm the co-founder of the architecture practice SPAN together with Dr. Sandra Manninger, who is currently teaching at NYIT in New York. The lecture tonight is entitled Neural Architecture, Design and Artificial Intelligence, and is based on the book that I published last year about basic thoughts on AI and architecture. It should not be considered a technical manual. It is more a theoretical basis for how we as architects can think about using AI in our discipline, meaning that it interrogates the ontological qualities that come along with working with a tool that basically learns, which is a first one. Tools normally do not really learn, and a variety of different observations and comparisons also to former techniques and ideas in architecture design and how those basically tie in with this new tool set that we have in our hands. Primarily defined through neural networks. So the book was really helpful in basically summarizing several, I think about a dozen papers that we did from that I did from 2017-18 to 2020, I would say 21. And it helped to really formalize also the content of what we did through these papers in a full picture. So what is meant when I talk about, so basically just let me put that it starts with chapters like "This building does not exist," which is an attempt of a theory of neural architecture, to computational vision as a design method, to questions of style in architecture and artificial intelligence and architecture. It contains also an entire chapter on aspects of language and architecture, which has become very current with the emergence of diffusion models like Disco Diffusion, Midjourney, DALL-E, and so on. Chapter 6, for example, deals with the important question of how machines learn to plan, and continues with the question of applying 3D mesh models in neural network algorithms. The book ends with a statement about the politics of neural networks and artificial intelligence. And Mario Carpo was so kind to provide the preface for the book, which consists of a fascinating story about the compositional techniques used by ancient Greek sculptor Zeuxis in the creation of a Venus statue. And he compares that to, for example, how we use generative adversarial networks at SPAN for our projects. So neural architecture is the field of architecture that is primarily preoccupied with interrogating the emergent field of artificial neural networks as a method of designing architecture. ANNs, as artificial neural networks, can be described in short as a sequence of mathematical algorithms that are capable of registering latent correlations in a set of data. So in this lecture, I present an attempt to utilize deep learning and machine learning to capture the salient features of existing architecture in order to interrogate this data for their underlying architectural qualities. What is meant by underlying architectural qualities? The rational explanation would include aspects such as spatial layout, sectional distribution of volumes, the dialogue with its environment, the volumetric balance, the material qualities of the design, the structural properties, and so on and so forth. All of these are things that can be explored with the help of machine learning processes. However, the ambition of the projects in this lecture maintains that architecture is more than just an assemblage of rational properties. This might explain also the obsession with neural art, which represents an excellent mirror of our contemporary age, particularly regarding our shared agency with quasi-intelligent machines and their observation of the world. Can architecture do the same? Can neural networks help interrogate the latent layers within the geological deposits of the history of architectural discipline and then assemble those found features into unseen designs? What is the context of which this idea emerged? But first and foremost, why use AI? There is a very quick answer to that. It's better to teach machines how to learn instead of how to do things. It's better to teach machines how to learn instead of how to do things. So let me give you an example to illustrate that notion. I'm sure that every one of you has seen videos like this before. This is basically an assembly line. How basically car production used to work until the late 1960s. You had a set of experts who basically welded together the pieces of the car. They were really well trained. They knew exactly what to do, and it needed a lot of manual labor to put all these cars together. I have here two examples. One on the left side is from the Volkswagen Beetle factory line from 1973. And the right one is from the Ford Dearborn assembly line in 1962. So not much changed in that time. However, what is clear is that you need a lot of experts to really make this work happen. And this is, of course, it is limited in the speed, and it's, of course, also financially a question of how to do this more optimized. Well, what happened in 1967 was the introduction of the Unimate, the first industrial robot in car manufacturing. And this was done by General Motors in their factory in New Jersey. And since then, of course, it went on to become the success model of car production, right? You have like a robot or several robots, as you see here, and they basically weld together the pieces of the cars. So that's basically a step towards automation, but it has nothing to do with AI. Now, in the time since 1967, when the Unimate was introduced by General Motors to today, the car industry has collected billions of data points about welding points of cars, right? That's logic, no? Because every one of those needs to be trained to weld the car. How this is done, and if any one of you has worked with a robot, he knows there's a pendant, right? And you can use this pendant to literally train a robot to do particular things. As in this case, for example, welding the points of this specific car model. Now, the disadvantage of this mode of production is that whenever there's a change in the model on that assembly line, if another car model needs to be produced, the robots have to be retrained so that they can weld the new points of that new car. Now, that, of course, is also very costly and very time-consuming. But because the car industry has this enormous amount of data about welding points of cars, they can basically take those points and train a neural network, train a machine to understand not necessarily the particular welding points of a particular model of car, but welding in general. Like, what does it mean to weld? And what does it mean to weld well? And once the machine or once this neural network is trained to understand that, you can combine it with machine vision, meaning that the machine, the robot, can understand there's a car coming along here that I need to weld. And because of the training, I understand that this point, this point, this point, and this point are good points to weld. Then the huge advantage of this new method is, first of all, you don't need to retrain the robot all the time. And secondly, every single car that comes along that assembly line can be different, because for the robot it doesn't matter. He learned what it means to weld, right? So he can automatically and continuously adapt to the situation. And adaptability, by the way, is one of the key features of intelligence. Okay, now to something different, less technical: the rise of neural art. Yeah. Some of you might have seen this painting before. This is the portrait of Edmond de Bellamy, which was created by the Paris-based art collective Obvious in 2018. It became quite famous because it sold at Christie's for around $450,000, and it was allegedly the first entirely AI-based piece of art. The name of the piece of art, Edmond de Bellamy, might be a tribute to the inventor of the generative adversarial network, the GAN, Ian Goodfellow. But honestly, more importantly than the price that it fetched or the particular AI technology that was used, there are some fundamental questions that came along when this painting made its rounds in the media, which is aspects of agency, authorship, sensibility, right? These questions appear through interrogating this piece of art, right? Who is the author? The art collective that came up with the idea to use a neural network? The programmer who actually set up the algorithm, or the hundreds or even thousands of artists who were present in the data set used to create this painting. So who has the copyright, for example, on something that was not created by humans? So there's a lot of questions that come along here that are important for every sort of artistic production, including architecture. So the rise of neural art became very visible around 2018 when artists such as Sophia Crespo, Mario Klingemann, Memo Akten, and others embraced neural networks as an artistic technique. And it was not only visual artists who did this, there were also musicians called neural musicians, such as Holly Herndon, Arca, Yacht, and Dadabots, who use AI to make their artworks. Yeah. And funny enough, also literature, of course, is part of that. They were actually one of the earliest adopters of neural networks to create art, to create their literature. Around the same time when we saw this, so we were working around 2018 on things like this, which is basically trying to understand how we can wrap our heads around this new technology. This was already done in collaboration with people at Michigan Robotics, particularly Alexandra Carlson. He was a PhD student at the time and helped us to set up the algorithms used, for example, in this case, where we created a data set of Gothic architecture and then created a latent walk through it. So the question that we had also at the time was things that I mentioned already before, like what's the authorship? Who was the agency in this project? It is a really new methodology of interrogating existing data. We were really discussing what a sensibility means in a posthuman design ecology. So, but what is the architect's role in a context where the sole authorship is not in the human anymore, but when agency is shared? These questions help us interrogate design embedded in this new ecology of design. And for us, for example, it was interesting that when we started to do what you see here, this was like our first attempts to somehow generate plans using artificial intelligence. And at first glance, it was really exciting and fascinating to see that we can actually train a neural network with thousands and thousands of sections or plans, and it will generate something that resembles plans. On the first glance, I was like, oh, great. We can now start automatizing plan making for architecture. Fantastic. However, there was a little problem here that if you look closer, every educated architect will recognize that these sections or these plans do not make a lot of sense. And that is because the semantic information in these sections and plans are missing. The neural network does not have a concept of what an elevator shaft is, or a staircase is, or a room even is, or even specialized rooms like lecture halls, concert halls, apartment buildings, apartment plans. It does not understand what a living room is, or a sleeping room, or a toilet. It doesn't have concepts for that. For that, it needs semantic information. And also, those plans have something that I would describe as follows. They have something that I would describe as estrangement and defamiliarization. So estrangement and defamiliarization are artistic concepts that were developed by people like Viktor Szlowski. He actually coined the term ostranenie or estrangement in his paper Art as Technique, which was published in 1917. And theater director Bertolt Brecht really applied this method to his plays. And what Sigmund Freud has to do with it, I'm going to tell you in a minute. Defamiliarization or ostranenie is an area of consideration regarding the discussion of architecture design within the aid of neural networks. The interesting part about this technique is that it describes an artistic method that provokes the audience with imagery depicting everyday things in unfamiliar or strange ways. The goal was to provide the audience with the opportunity to gain new perspectives on and observe the world through a different lens, through techniques that introduce abstraction into the aesthetics of realism. So what you see here on left and right is on the left side, it's a latent walk through a data set of brutalist buildings that we used StyleGAN 2 to do this. And then on the right side, you see the same latent walk, but with an additional style transfer on it. And what we use to style transfer on this is basically the style of Picasso. And once you know it's Picasso, you start to see it. But what both of those really maintain is this idea that I just described about adding a layer of abstraction to the design that provokes the audience to observe that imagery in a particular way. So estrangement and defamiliarization have a longer history. They were present in the works of Georg Friedrich Hegel, Karl Marx, Viktor Szlowski, and as I mentioned already, Bertolt Brecht. And Sigmund Freud's contribution to this discussion, he wrote an essay called Das Unheimliche, the Uncanny, where Freud defines the uncanny as deeply rooted in what is known to individuals as common or familiar, but the deviations from the familiar, the defamiliarization aspects of life, result in emotional responses akin to fear or curiosity. So architecturally speaking, and in the context of the things that have been generated throughout the last year, this is an example I like to show that describes that effect quite well. If you look at this image, you all as trained architects, you will immediately recognize particular architectural features in this image, particularly in the building in the front. So we have Fensterbänder, we have like very angular features, cantilevering elements. So there's like a bunch of what you would consider modern stylistic elements present in this building or features. But on the other hand, there's also things that are really questionable, like, for example, the way the building touches the ground. It's unclear what's happening there. And this is what this was particularly interesting in this result, is that when the neural network was not capable to really reconstruct features clearly, it sort of made things up. Is it growing from the ground? Is it carved from the ground? Is it melting on the ground? And then the same question with the ceiling, right? Is this broken? Is this destroyed? Is the floor missing? Is this intentionally done like that? Is it part of the idea of the concept of the project to have that rugged top? So because it has those aspects of estrangement where we have familiar things that we recognize, architecturally speaking, but at the same time have features that are not necessarily completely clear to us, is what provokes us to look at this image and have this maybe uncanny feeling. Yeah. I've been stating that I think that working with artificial intelligence in architecture is the first genuinely 21st century design method. And I want to try to give you evidence for that. If you think about computational design methods that have been applied in architecture in the last 20 years, to 23 years, it becomes very quickly clear that all these methods already existed in the 20th century. Parametric modeling, agent-based modeling, mesh modeling, NURBS modeling, scripting, versioning, and so on and so forth. Like all of the things existed already in the 20th century and were refined in the last 23 years. What we see happening currently with in architecture, what I call neural architecture, is a new paradigm. Not only intellectually and culturally, but also technically, because what we see today was not yet possible even a decade ago. Let me give you a couple of examples of how this can be applied in architectural projects. First, I will start with the robot garden, which was a collaboration between SPAN and Michigan Robotics, specifically with Alexandra Carlson, who helped making all the algorithms for this project. So the robot garden was basically a commission right next to the new Ford Robotics building on the North Campus of the University of Michigan. And the commission came along because the director of robotics had heard that we have been working with Alexandra Carlson on some novel design methods based on the research they basically do in the building, right? Because a lot of the things that we used emerged from things like machine vision. And that's their main expertise there. And what they asked for was, okay, if you can use those methods to do the following, we need a site that has a variety of different ground conditions, that has a variety of different steps, and that allow us maybe also to flood it so we can use those features also in wet conditions to test the robots. And why they need these particular features is because they're training the so-called last 100-step problem on that site, which means the idea is if we have if you want a robot to deliver goods directly to your door, the distance from the delivery van to the door is the most difficult for the robot because he might encounter a variety of different ground conditions, gravel, concrete, slabs of stone, but also he's always going to encounter steps, or very often at least. And so they wanted to test the robot with a variety of different step lengths and step heights and so on, and a variety of different ground conditions. So what we did was basically we combined a variety of different AI methods here to create the design. We used deep dreaming, we used 2D to 2D style transfer, we used 2D to 3D style transfer, and we used style gun 2, as far as I remember. So this combination allowed us to do a variety of different concepts and ideas on top of it. And there's one thing I want to show you here, which I recently got from Michigan Robotics, which is the way that the robots perceives the robot garden. By the way, when I talk about this, it's actually a very interesting commission, because if you think about it, this is not architecture for humans, right? This is basically a project that was designed by machines for machines. Yeah, with very little human intervention. Yes, we needed to polish things afterwards once the design was finished. But just to give you an idea, this is a small part of the set of satellite images that we use to create the features on the site. So we trained a neural network on satellite images and then deep dreamed or style transferred onto the site. And that training was really interesting, because it does not always give you something that's useful. On the contrary, at least for us in this first attempt, we need to do many iterations to get something that was really usable as a final design. What you see here on the lower row of images, I don't know how clearly you can see that, but this was our deep dream process where we tried to, so first of all, I have to say, we created a data set of steps, fountains, and columns, because those were sort of features that would happen on that project, right? The steps, of course, were the requirement that we got. We have to do steps. The fountain, because they wanted the water feature, right? That can actually flood the ground. And then the columns were those very thick poles that you probably saw also in the video. Those poles are necessary to mount sensors and other equipment when they're testing the robots. And the funny thing is, in this lower row, we figured out that we didn't know why it's creating a lot of vertical features in this deep dreaming process. And then Alexa figured out that the reason why it's doing that is because in the data set of fountains, we had a lot of fountains with water sprouts. So it actually learned the feature of a water sprout because it was repeating so often in the data set. It thought I mean, AIs don't think, just to make that clear, but it somehow learns that a vertical feature is part of a fountain. This is one of my favorite results, even if we didn't build it. I thought this was hilarious and great that the neural network suggested this as a solution for the robot garden. And I think that might be how robots actually see a garden. So what they think a garden could be, or what they think architecture could be. Again, I'm using the word think. Humans really have the tendency to anthropomorphize everything, and I may not be completely immune to that. And let's talk about something different, though. Text-to-image generation is basically what exploded last year and created a thing, the huge interest we are seeing in the architecture discipline for artificial intelligence. Before that, there was not that much interest in it. And if it actually even arrives in something like John Oliver's show, then it's clear that it has arrived completely in the middle of the mainstream. So AI applications have become mainstream, or at least they have moved into the field of vision of mainstream, because they were already before that part of mainstream. You cannot imagine how many AI applications you're using on a daily basis, even without noticing it. But as we're talking about text-to-image generators, I like to use this quote when I talk about this, which is "The limits of my language means the limits of my world" by Ludwig Wittgenstein. Of course, this is not entirely true anymore, because in recent times, text-to-image generators are also changed to allow you to use images as part of your prompt. so that it is not anymore only about language. As sort of like an early project in that vein of text-to-image generation was a competition that we made called the 24 High School Project in Shenzhen, China. It used actually something called an attentional generative adversarial network, attentional GAN for short, which allows attention-driven multi-stage refinement for fine-grained text-to-image generation. Attentional GAN can synthesize fine-grained details at different subregions of the image by paying attention to the relevant words in the natural language description. In addition, a deep attentional multimodal similarity model computes a fine-grained image text matching loss for training the generator. It used the Coco dataset, common objects in context, yeah. A detailed analysis is also performed by visualizing the attention layers of the attention GAN. So this project was actually done before things like GPT-2 or GPT-3 were developed and before diffusion models became popular. But the idea is basically the same. We actually used parts of the program that was called for in the competition and combined them with a surrealist twist. So we said something like, this gym has 2,000 square meters. It has 2 basketball fields, changing rooms, a swimming pool, and it's standing on yellow canary legs, for example. This was also, I would like to thank actually Yining Yuan here for the amazing work done also on this project when you worked for us in the office on this. We actually used the resulting images and the color patches that it produced, and then used actually Grasshopper to create the volumes out of it. So it was really a combination between using an AI method and then using Rhino and Grasshopper to finish the project. Because we noticed something working on this project, which is quite essential, which is that a neural network, at least at the time, was not able to create the interior and the exterior of the project at the same time. So it could only do either the exterior or the interior. It was not possible to concatenate the processes to do everything at once. So what we decided to do was to take the shells that were provided by this process, the exteriors, and then really fill in the interiors in a rather pragmatic, simple, straightforward fashion. Yeah, keep it a little bit more simple in the way how it operates on the inside. Yeah, this was an interesting moment for us in terms of understanding that there is something like text-to-image generation, and then early last year. Like around January last year, I found disco diffusion. It's the first diffusion model that I started to work with. And I have to say that I really like to linger around the chat rooms of media artists. And because they most of the time find these things first. And I thought, oh, that's exciting. So I made it. One of the first things I did was this endless plan animation. And I started to ask myself, like, why is it that architects got attracted so quickly to this AI model in contrast to other things like GANs or convolutional neural networks? And I think one of the things why it became so attractive to architects is because it has this enormous similarity with the working through a problem in an architect's minds. So if you think about it, a conventional architect or an architect, I would say, can take a piece of paper and then start drawing a plan or sketches a plan with a pen on it, and then iteratively we work through the problems in this plan, like making another version, another version, another version, another version, until you find the one that solves the problems that you have with the specific request to you. And the image you see here is a similar problem, but working through models, right? So iteratively looking for the volumetric balance in a building by creating variations as models. One more model, one more model, one more model. In this case, it's 28 models of the same project, just trying to find that right balance, right? And what Midjourney does, what diffusion models do, is they amplify this notion enormously by the way how it operates. It gives you four solutions, and then you can either reiterate, or you find one that you like, you expand it, you make it bigger, and then you make variations of that one. I made a little bit of a math, and this is outdated by now, but it's still the one I still have, which is what you see here are not all of them, but a good chunk of the images that I generated in Midjourney last year. And I made the calculation that from like April, early May last year to August, I generated 72,000 images, 72,000. And I'm not even a power user. So how do these diffusion models actually work? So this is just a brief technical explanation. I'm not going to go into much detail here. So, but what happened is that in 2015, there were enough labeled images to think about the following. So what I mean by enough labeled images was there were enough images that were labeled, this is a person, this is a bridge, this is a statue, this is a lamp, this is a car, this is a dog, this is a tree, whatever. So individual elements, individually labeled images. And somebody came up with the idea, okay, if we have enough of those, we might be able to train an algorithm to automatically create a caption of an image. So when the algorithm sees this image, it can describe it as people walking on a bridge. I hope you're following. And then somebody very quickly came up with the idea, what happens if we turn that process around? And we say people walking on a bridge, and then let a machine generate the image. This person was Elman Mansinov and his colleagues at Amazon Web Services. And they were really interested in that it can particularly create novel scenes. Of course, they really quickly released a paper called Generating Images from Captions with Attention. And these are the images that were in the paper. These were the first tests of generating images with text. So the first one says, a stop sign is flying in blue skies. And the second one is a herd of elephants flying in the blue skies. The third one is a toilet seat sits open in a grass field. And the fourth one is a person skiing on sand-clad desert. So if you have a lot of imagination, you might see those things in these images. But to be really fair, at the time when this was done, which was 2016, the only thing you could generate, or the only resolution you had to generate images was 72 pixels by 72 pixels, because that's basically the standard size used in the vast majority of machine vision processes. So even in your Tesla, they are trained on 72 by 72 pixel images, maybe better ones these days, but that was the standard at the time. So what do diffusion models do? They take existing images or existing data and then destructure the data continuously by adding noise. And this happens in several steps until it's only a noise image. And then the diffusion model does the following. It takes your prompt and then basically reverses the process and starts to structure the pixels again into an image based on your prompt. So this is really in short and simplified, yeah, but that's basically what's happening there. Now, what does it mean for architecture? Let's take something like a prompt like this one. And yeah, we can debate this in a second. So I'm going to prompt Mies van der Rohe building. It'll create something like this, right? This is probably the route of the lazy architect. Yeah, if you can, of course, take a name of an architect, living or dead, and basically imitate the style of this architect. And Midjourney or this diffusion models will give you good solutions for that. The question is this a particularly interesting way of using that technology? Either way, let's keep going. I'm using the prompt here, section drawing through an opera house. And we're going to do a little comparison here. This is Midjourney version 2. This was done in May this year. So, yeah, interesting. I mean, it's certainly not the section through an opera house that is properly shelled out, but you could use this as a starting point for an idea of what this opera house could become. And this, in my opinion, is one of the strengths of using diffusion models, is the ability that it can mine through the history of our discipline or humanity in general, and then use what it learns to apply it to your imagination. Does that make sense? So you can mine the history of visual production from every era of all humanity, and then use your imagination to extract something that might be different or novel to you. By the way, I want to mention that the data set used now to train Midjourney, Midjourney version 4, V4 that you see here, is the so-called Lion dataset. And the Lion dataset has more than 5 billion annotated images, image text pairs. I don't think that all of them are used in Midjourney. It seems that it is using only the so-called Lion aesthetics dataset, which is still 250 million images. So it's really a large deposit. Yeah. So this is the comparison now, section drawing through an opera house with the new version of Midjourney. What I want to point out with this is that the older version somehow was able to infuse more of what I described as defamiliarization or estrangement in this section, versus this version, the newer version of Midjourney, rather catering to something that I would describe as cliche. It's the cliche of the Disney opera house that is trying to convey here. It might be possible with a little bit more refinement in the prompt to get rid of it, but it's of course much more work than with the older version. And I don't know if I really want to do that. Either way, interesting for our conversation is, let's say something more like a provocative generative model versus cliche generator. Yeah. This is an interesting one too. What happens if I ask an AI what's the most beautiful house in the world? And this is with version 2. And the same question now with the new model of Midjourney. What is the most beautiful house in the world? Okay, so if and I'm going to generalize here, if AI thinks that is the most beautiful house in the world, I'm not worried about architects. At the beginning, I did a lot of really fun experiments with Midjourney, like a house made of feathers, a house made of Kobe beef, a hairy villa, and new Piranesi etchings, a scaly house, and so on. It was really fun to try those things. And I remember that a colleague of mine recently told me that when he saw the house made of feathers that I put on Instagram, he started to take AI serious. Let me put it that way. Yeah. And then also, of course, the familiar and popular tectonic facade studies and many, many alpine villas. I don't know how many I did, but it was really an obsession of mine for a while to do these alpine villas. And I don't know how many of those are posted, but a lot of them. I'm going to jump a little bit over those here. More estrangement, more defamiliarization. And of course, it seems that I really like this image that I have to put it twice into a lecture. But nonetheless, the main question that arises of this is also that these tools leaves us with many questions about a strange new emerging aesthetics, which I like to call the aesthetics of the multitude, because it is based on this enormous repository of human creativity, and out of that emerges something that somehow evokes the feeling of something novel, different, and exciting. It's getting also better and better in doing sections, as you see here. But it still has the same problem, like with the really crude first attempts to do plans that I showed you before. It still does not understand the semantic information in a section. So these sections look interesting, but if you really start to interrogate it architecturally, you'll figure out very quickly that it doesn't make any sense. Another project we worked on is the Generali Center in Vienna, Austria, where we use StyleGun 2 to create the project. The Generali Center is a building on one of the main shopping streets in Vienna, the Marilferstraße. It's a combination between a shopping mall, offices, and apartments. And there is already a building there with the same name, but there is considerations to replace the building for a variety of reasons. And this was, so to speak, our pitch for that project. So we created a data set of brutalist buildings, thousands and thousands of images that were scraped from the internet to create the data set. Then we trained the data set on that. We trained it. And the training results they were provided by a latent walk. You saw it before already in the lecture, but it was used actually for this project. So what we did was then, from the human side, so to speak, we selected a couple of images that we thought are interesting and provocative in some way, shape, or form, and then applied something called a pixel projection to create a 3D model out of it. And that 3D model was then the basis for the rest of the project. And the interesting thing in comparison, for example, with the high school project that I showed before, is that in this case, we also got an interior. It was not all usable. It was not all perfect, by far not. But it was something that we could start working with. And I think this is the interesting point about using neural networks in AI, is when it starts to become a dialogue between what the machine, what this learning system can give you as an architect, and how you respond to it as a human by further intervention. Yeah. So I don't think this is a one-way street. I don't think this is going to be total and full automation. I think it's going to be something that might expand the abilities of our creative minds as architects, and might empower us to include more of what we sometimes think we know. Yeah. All of what you saw here, all of what you see here, which is sort of like pulled out of the building, were elements we had to add. Yeah, staircases, floors, etc., etc. So you see that there's like really this sort of conversation between what the machine provided to us with this intricate, really interesting volumetric elements. There's certainly learned brutalist features and so on, and then how we humans respond to what that system basically spit out for us. And the most recent commission in that area is the Deep House, which we actually created using StyleGun 2. This is an interesting commission. This is a commission by a neurologist, an Austrian neurologist, who has a site in the mountains. And he had heard that we are using neural networks for designing architecture, and he was fascinated by the idea to get a house that basically represents in some way, shape, or form his own discipline. Yeah. But he had one condition. The condition was it has to be a mid-century modern house. It had to be a mid-century modern house, and we said no problem. So what we did, of course, I mean, we collected again like elevations, thousands of elevations of mid-century modern houses and plans, and started to play around with it and see what can we generate using StyleGun 2 out of it. So these are some of the results of the latent walks, again, from this similar technique to the Generali Center. And to our surprise, it worked really, really well. So it did not only provide us the exterior, it did not only provide us parts of the interior, it provided us the whole interior in this case. So every single element that you see here in this interior, we didn't touch that anymore. We just basically assigned functions to it. Yeah. So we say, okay, this block looks like this is going to be the kitchen. This is going to be the study room for this doctor. I really like the roof, how that came out. Yeah. So this is all quite fascinating to us. And this is the last project that I'm showing here in this series. This is going to become the children's room, I think, of the project. So apart from doing all this work on our own designs with SPAN and writing about AI and architecture, I also founded something called the Neural Architecture Group. It's a set of people, it's a group of people interested in similar topics. Daniel Polochan, Immanuel Ko, Sandra Manninger, and myself. There's also the website aiarchitects.org, where we connect various different positions on ideas on AI and architecture. We're adding more people regularly to this, to expand the how you can look through different ideas pertaining to AI and architecture. And Taubman College was so generous to allow me to the foundation of the ARIL laboratory, the Architectural Artificial Intelligence Laboratory. You can also find us at ar2il.com. That shows all the research we're doing. I also have to say that very different to the lecture I gave today, the laboratory works a lot on very pragmatic problems in terms of AI and architecture, meaning we're working on creating data sets for architecture use, because that's one of the biggest problems we have in architecture when using AI, is that we don't have good data sets. We're working on automated plan generation, particularly for social housing. And we are also working on 3D model data sets, because there's nothing out there at the moment in terms of really good, well done 3D model data sets for AI applications in architecture. There's also the YouTube channel Remeshing-AI, which it also contains, by the way, tutorials on Python usage and on how to set up a variety of different neural networks, but also a bunch of lectures like this one. So if you want to check it out, give it a like. Yeah, you know how this works. And then, of course, the publications: Neural Architecture, Design and Artificial Intelligence, Machine Hallucinations, which I had the pleasure to co-edit with Neil Leach. And then upcoming is the pendant to neural architecture, which is Architecture in the Age of Intelligent Machines. This book with Springer is sort of like the if you talk in terms of Dr. Jekyll and Mr. Hyde, then Mr. Hyde is the neural architecture book, and Dr. Jekyll is the Architecture in the Age of Intelligent Machines book, because this will contain really a very pragmatic rundown of all the algorithms, the mathematics behind it, the code behind it, etc., etc. Thank you very much for listening. It was a pleasure, and I hope there's going to be some questions from the audience or also from our co-hosts. Thank you.